Hello and welcome to another video, this time on Danielle's Demov dilemma. Okay, right, these kind of questions, these always, they're pretty common, to be honest, particularly the first part, they get you to do that, and then they quite often at the end tweak it a little bit and get you to work out, some kind of weird expression for sine squared of pi over 5 in this case. Okay, so I'm doing the first part mainly to remind myself how this works. I haven't taught this year, and you do forget. But okay, I think if I've got to prove that, there's two different ways. Sometimes I have a power here and multiples of the argument there. Sometimes I have powers here and a multiple of the argument there. And they're quite similar but different techniques, really. Okay, so first thing I'm going to do here is I'm going to note that z to the 5 would be cos 5 theta plus I sine 5 theta. So I reckon this one's the one where I need to take the real part of a binomial expansion, where I go, what I'm going to do first is say, let z equal c plus is, sorry, not let z equal, let c equal cos theta, s equal sine theta. Do it for your own sanity in these questions. Let c equal cos theta, you must write that down in the exam as well, and s equal sine theta henceforth, yeah, because it's just going to save you more ink in the long run. Okay, because what we could do then is we could point out, well, cos 5 theta, it's dangerous having 5 theta and s in the same question, plus I sine 5 theta, well, that must equal z to the power of 5, but z is c plus is now. So I could just do c plus is on this side to the power of 5. Now you've done loads of questions in a textbook like this. We're going to have to do our binomial expansion, and you want to be confident with this. Binomial coefficients, oops. So we're going to have 5 c to the 4 is plus 10 c cubed is squared plus 10 c squared is cubed. I'm just thinking about Pascal's triangle here, if I'm honest, plus 5c is to the 4 plus is to the power of 5, yeah? Okay, so we've got that. Now I always find it's useful to remind myself that I to the 1 is I squared is minus 1, I cubed, well, times that by I, you get minus I, and I to the 4, well, then you're back to minus I times I, which is minus I squared, which is minus minus 1, which is 1, yeah? And basically powers of I are periodic, because all you really do is rotating round the plane, basically there, 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 there. That's why it's period 4. Like each time you times by I, you rotate 90 degrees, don't you? That's what a complex number is. It's a rotation. But okay, so knowing that, we can now simplify this to cos, well, c5 plus 5i c4s plus 10c cubed, well, minus 10c cubed s squared. We're not actually going to use that one, but we'll see that in a second. Now this one's going to be minus 10c squared, 10i c squared s cubed, and then finally we've got I to the 4 is 1, so that's 5c s to the 4, and then minus, you're going to, I to the 5 is going to be I, so yeah, sorry, plus, it goes minus minus plus plus in this. I to the 5 is just I, s to the 5. Okay, cool. We can now just look at the imaginary parts, because remember, this is cos 5 theta plus I sine 5 theta. So if we now equate coefficients, we know we need that is going to be equal to this without the I, this without the I, and that without the I. We can ignore the real parts, in other words. So we can now say, therefore, sine to the 5 theta is going to be equal to 5c4s minus 10c squared s cubed plus s to the 5. Okay, now we want 16s to the 5 looking at it, so where's that going to come from? Well, let's get rid of our coses now. So we get sine 5 theta is 5. Now, c squared is 1 minus s squared, because c squared is cos squared theta, and that's 1 minus sine squared theta. So let's have that as 1 minus s squared, and then square that, and times it by s. Note that is a 5, and that is an s. And that is an s. Sorry about my handwriting here. It does get quite awkward when you've got 5s with s's. That's the one downside. Minus 1 minus s squared s cubed and plus s to the 5. I'm fine with the s to the 5 because I want everything in terms of sine theta. And so sine 5 theta is going to be equal to, now just multiply it out, you're going to have 5s, 5 times by, oops, let's multiply it out carefully. Let's just do it as 1 minus 2s squared plus s to the 4 multiplied by s minus 10 s cubed plus 10 s to the 5 plus an s to the 5. Oh, that looks like a 5. Let's do it as an s to the 5. I'm trying to make it look like an s anyway. And now just simplify. So we get sine 5 theta is, right, tick as you go, you're going to have a 5s, 5s to the 5 there, plus a 10s to the 5 is 15s to the 5, plus another s to the 5 is 16s to the 5. Tick as you go. Okay, then the cubes, well, I've got a minus 10s cubed minus 10s cubed, that's minus 20s cubed. And then I've got a 5s right there, so plus 5s. And I'd write that at the end as they wrote the result. And we've done the first part. Okay, cool. Now, how does that link to the second part? Well, let's bring it down here so we can see what we're doing. Well, for the second part, notice that this is very similar to this. It's just had one factor of sine theta taken out. So if we note now that, like, as sine 5 theta equals 0. I mean, it wants us to find these roots first, yeah, by considering the solutions of that. That's really easy to find because 5 theta is going to be 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. Just think of the graph. And so theta is all of those divided by 5. So we get these, yeah. And I'm looking ahead in the question and seeing that and thinking, yeah, I'm on the right track here, you know. Okay, well, that's really nice because we know the roots, therefore. So roots of 16, now let's take out of sine 5 theta here as well, straight away. So the roots of sine theta times 16 sine to the 4 theta minus 20 sine squared theta plus 5 equals 0. The roots of that must be all of those, yeah? Yeah, that's the roots of them, yeah? So we know the roots, yeah? Are, 0 pi over 5, 2 pi over 5, 3 pi over 5, 4 pi over 5, yeah? Clearly as well, that one corresponds to that one, yeah? Because sine of pi over 5 isn't 0. So, only sine of 0 is 0. So that one must go with that one, yeah? Now, the remaining roots, if we let x equal sine theta, yeah, then, this is just a substitution essentially, and we're seeing that 16 sine to the, 16x to the 4 minus 20x squared plus 5 equals 0. Well, that must have the same roots as this one, but just with x, after we've taken the sine of the roots, if you see what I mean, because these are the x values for this, yeah? In other words, this is where sine, the same roots which solves this equation. Like, let me just write it out. I think it's easier to see when you actually write it, yeah? Hence, the 4 remaining roots are we already know that we need like sine of these roots because we already know these roots correspond to where theta is that. We've already decided to exclude this one with this one. As theta is that, well, sine of theta, which is x, is going to be sine of pi over 5, sine of 2 pi over 5, 3 pi over 5 and 4 pi over 5. Sometimes students ask me, oh yeah, well what about all the other roots, which, if you carry on going here, it's got an infinite number of roots. It's true as well, but they will give you exactly the same value, yeah, because of the symmetry of the sine graph. That's the point. That's why, it's not going to make any difference if you carried on going. You're just going to have roots which correspond to these roots. And remember, these roots correspond to each other anyway, because sine of pi over 5 is the same as sine of 4 pi over 5, because sine of theta is identical to sine of pi minus theta. Yeah, that's always true, isn't it? That's just what we do when we do inverse sine. We do 180 minus or pi minus to get our other roots. So that one is actually, after you've taken the sine of it, it's the same as that one, yeah, and this one is the same as this one after you've taken the sine of it. So these are the four remaining roots. In other words, this has like repeated roots, yeah, like because sine of 4 pi over 5 is the same as sine of 4 pi over 5. Okay, right. So I've found them in trigonometric form, yeah, and now I've got to show clearly this. Well, the whole point is you've got in part C, like you've got the roots now for this, yeah, and you've got a disguised quadratic, yeah. 16x to the 4 minus 20x squared plus 5 could be solved by saying, okay, let u equal x squared, yeah, because this is a disguised quadratic standard approach. Oh, u squared, sorry, minus 20u plus 5 equals 0. Okay, so what does u equal? We can now just use quad formula if you like. 20 plus or minus the root of b squared. 200. What's b squared? 400 minus 4 times 16 times 5. I think that's 320 over 32. Okay, well we can simplify that to, okay, 20 over 32 is the same as 5 plus or minus. Oh yeah, I can also, that's root 80. And that looks to me the same as 4 root 5. So we can simplify that to 5 plus or minus root 5 over 8. Yeah, that is lovely. That is really, really nice. We're close to the answer now because that's 5 minus root 5 over 8. Now, we've got two possibilities here, yeah? Either u equals 5 plus root 5 over 8, or u equals 5 minus root 5 over 8. Now, let's try and tie this back into what we had before. Remember, u is x squared, but x is sine theta, and so u is sine squared theta. And what's more, we know that this is solved when we know these are the roots. Yeah, we know that sine squared of like maybe it's pi over 5. Yeah, let's say maybe it's pi over 5 equals 5 plus root 5 over 8. Yeah, let's just have a think about why, whether that's true and why it's true. Yeah, we've got exactly this, but they're saying it corresponds with this one. Let's try and think about why that would be true. Well, okay, you might at first think, oh, maybe this is going to be a number like bigger than 1 or something like that, and you might think, oh, sorry, my phone's ringing. It's actually not, though. It's not bigger than 1. That's not the reason why you should exclude it or anything like that. It's about where the roots occur on the sine curve, yeah? Like, when you have a root of sine of pi over 5, 2 pi over 5, 3 pi over 5, and 4 pi over 5, obviously they come in this order, yeah? So this is pi over 5 and 4 pi over 5. Ooh, 4 pi over 5. And this is 2 pi over 5 and 3 pi over 5. Yeah? Now, we've got to decide which one's which. This is the toughest part of the question, really. Which root should go where? Which root belongs with this root up here? Well, if you're, firstly, when you've squared it, and this is going to end up, yeah, so, sorry, I'm fluffing my explanation here. Can I just draw it in a clearer way? Basically, the value of the y-coordinate should be lower, yeah, for pi over 5. You can see it on the graph, yeah? Pi over 5, sine of pi over 5, is less than sine of 2 pi over 5, yeah? So clearly, sine squared pi over 5 should be less than sine squared of 2 pi over 5. Yeah? And so which one of these is the smaller? Well, that one's clearly larger than that one, so that's obviously wrong, yeah? I'm just going to justify it like this. I'm going to say, hence, sine squared equals pi over 5, which is 5 minus root 5 over 8. I'm going to show the examiner I really know what I'm talking about by pointing out that would give me exactly the same as that one as well. And sine squared 2 pi over 5 is equal to 5 plus root 5 over 8, which equals sine squared 3 pi over 5. Yeah, this is because sine squared pi over 5 is less than sine squared 2 pi over 5. Yeah, and I've justified it. Yeah, it must take the value of the smaller root. That's all it is. Yeah, I hope that makes sense. I do fluff my explanations sometimes at the end, but I hope that's clear. It's not an easy question at all. You've got to find the roots of basically trig function, which happens to be quadratic, and hence deduce the roots in trigonometric form of disguised quadratic quartic. Hence you can determine the roots of the quartic in trig form, and then because you can solve the quartic by treating it as a disguised quadratic, you can come up with this kind of like trendy expression for the exact value of sine squared of pi over 5. And that's it. Hope that makes sense and it's useful. All the best. Keep up the hard work. Bye bye.